introduce AlphaFold. AlphaFold came out, AlphaFold 2 is in 2020, I believe. The newest version, AlphaFold 3, came out last year. This was so impactful that they won the Nobel Prize in chemistry for this. AlphaFold is a product of DeepMind, which is a subsidiary of Google. So this is basically coming from Google. And this is kind of like one of their labs, almost like Bell Labs, where they're just like cranking out crazy AI shit. And their goal is literally to cure all disease. And so what they have been doing over the past few years is building a deep machine learning system that can learn to figure out just from the ingredients that go into a protein, which is like a list of amino acids, understand how it would fold into crazy ass shapes like this. So it just gets the kind of like, this is what it's made out of and can actually determine this shape, which are crazy. These are, these crazy things. The way it was able to do that is because there's like the protein structure data bank, which was a giant pool of data all these companies have put together. But they were able to make the system actually just from some basic information about the protein, like the amino acids, determine what this thing actually looks like in detail. So you can imagine now, going back to the malaria example, if you've been trying to make this malaria vaccine and you know that Dick and Balls has the protein that if you stop that, you cure the whole thing, but you don't know what it looks like. There's all these challenges that arise with trying to figure out the exact shape of the protein on those gametes. AlphaFold comes in, you can just feed it the amino acids. This did literally happen. This is going on with this malaria vaccine. And basically a years-long problem of trying to figure out what exactly this protein is, so how they could design a fix for it so that something can come in and stop it, is suddenly done in like weeks or days. It's something ridiculously short. I don't know if they said the exact timeline here. I don't remember. So this is like a massive breakthrough. Suddenly, one of the key pieces of the puzzle is now visible. We have the structure for it, and it was all made in a few minutes by a now open-sourced system. It's shared with for non-commercial use by Google that can dictate and has now, it's something like hundreds of thousands of protein structures. Oh, no, hold on. It predicted 200 million new protein structures in 1 year. So it's not like, oh, this is cool, it's kind of helping with malaria. It's like, the type of things that were holding us back from understanding processes and understanding how to attack certain systems went from a year-long process to now basically instantaneous. Mm-hmm. The ability to now start pursuing drug discovery and drug cures and figure out what's going on in a system just went from like an extremely slow, specific thing to like anybody can do this anywhere. Not only that, AlphaFold 3, which is what came out last year and won the Nobel Prize, it doesn't just predict the protein structure anymore. It also then simulates how that protein structure will interact with other proteins or with molecules or with DNA. So if you're a drug designer, if you are, for example, trying to come up with a drug that's going to, let's say, attack cancer cells or Alzheimer protein or something like that. Before, you had a blurry image of what the protein looked like. You came up with an idea of like, okay, here's my image, here's my idea for what a structure would look like that's going to come in and attack that thing. And you kind of guess and check. You then spend 6 months crystallizing your idea of what might work in a lab, then put it together with the target and see what happens. If it doesn't work, back to the lab. You're back to another like 1 year iterative loop. Now, AlphaFold 3, you do that digitally in minutes. So a drug designer going from years for every single iteration of a test to see what might help with malaria or what might help with cancer,
right,
or it might help with any of these other things, is now in minutes able to put it through AlphaFold and say, here's my idea for what might work on attacking the malaria parasite. It simulates it. It goes, that didn't really work. And you adjust from there. And you're doing cycles at literally, I don't know what the math on that is.
I mean, that's the magnitude is insane. You're saving so much time at the time scales you're talking about.
Unbelievable amounts of time. And not only that, you're making it now so many more people can participate in trying to come up with cures for things.
Okay.
You don't have to be a lab that has X-ray crystallography.
I see how you're arriving at your 10-year conclusion, because this is such an escalation at which you can search for these answers.
Like, it's so cutting out dramatic of how we approach these things that it is like almost unbelievable.
Yeah. That is so sick. I mean, do you come on? You might need to steal this villain chair for a second. I don't.
Sure. I will.
Yeah.
Well, the parasite, the malaria is like a living being, and maybe it should have a right to kill 600,000
We asked the malaria what he thinks about this.
Yeah, that's true. And there's more I'll kind of go on, but yeah, initial thoughts from you guys.
Here's mine. I mean, no, actually, I think this is incredible. I really have no negative thoughts, but I'm going to steal man or whatever. I'm going to try to get you to.
Yeah.
Okay, so this is from DeepMind Google website.
Yes.
They have an incentive to make it seem as cool and dope as possible.
Yeah.
Yes.
I've seen many technological advances on company websites that sound fucking incredible. And then we flash forward a few years and nothing's fundamentally changed.
Yes.
And we feel like, okay, where did that go? Where was that thing that was supposed to do X?
Yes.
That.
Yeah.
that I think that skepticism is super fair, right?
Yes.
The incentive structure to present these things as world changing
Of course.
solutions as soon as possible is something I totally understand. You know, I have read, when a blog post about some new blockchain thing and this is how it's going to change the way we interact with each other, and now I get that part of it, but to me, the part that is more believable about this is like maybe AlphaFold isn't quite as effective, or there isn't all the negative aspects of what they're explaining on this post. Maybe that's true.
Mm-hmm.
But the basic idea of using machine learning to shave down the time it takes to analyze data, to cut down on something like revising your approach to curing or attacking like the malaria parasite.
Right.
However, whatever the type of disease, whether it be
Right.
a parasite, a virus, or something else, that core idea holds very true to me.
Yes.
Like that is my understanding of machine learning, even before AI was like a big craze, is like this is the type of functionality it would be particularly good
Yes.
for. It can just cram all of this time it takes a human to do something into something so much shorter, and we can more efficiently trial and error our way
Yeah.
through solving diseases. And that part of it seems incredibly believable to me.
Yeah.
Like, and that is the part that I have faith in. Is like maybe it's not AlphaFold at the forefront of who ends
Sure.
up being the critical piece of what it takes to attack these problems, but this is an example or a first mover in this. And dude, this is kind of what I was hoping for. Is like this is the type of stuff that I think is so sick.
It's
So much more. It's like I would give up being able to ask my phone passing questions about language or research projects or how I feel today for
Yes.
this. This is like to me like the most important thing.
Yes, I by far agree. And actually, Dario Amadai, who I'll talk about briefly later because we've been going on for a while, that's also really what he says is like, look, when you get into medicine and biology, this is the most clear cut of like AI is going to dramatically improve our lives. Because we're not talking about, oh my God, lawyers are going to have this fucking AI chatbot. We're not talking about ChatGPT. We're not talking about AI art. All this stuff that has a lot more complexity. This is like, we're probably going to cure so many diseases. Demis, the CEO of DeepMind, who's running this, and again, won the Nobel Prize for chemistry last year for this. Like, there's broad scientific acknowledgement of how incredibly impactful this is. On average, it takes 10 years and billions of dollars to design one drug. We could reduce that down from years to maybe months or maybe even weeks, which sounds incredible today, but that's what people used to think about protein structures. And there's all these examples. Like, he's the one who said it'll, in the next 5 to 10 years, we'll have systems that are capable of not only solving important problems or conjectures in science, but coming up with them in the first place. It'll revolutionize human health. I think one day we'll cure all disease with the help of AI. And he said, I think that's within the reach within the next decade or so. I don't see why not. So some of these smartest people on the planet who are winning Nobel Prizes for their work are like, this is so dramatic of a leap forward in drug discovery and testing and improving that we might literally cure 95% of the things that have killed billions of humans, right? And if you think of your whatever close family member, and if they come down with some disease, and then this allows us to cure Alzheimer's or cancer or whatever else, like holy shit, that's a big deal. I would also give up everything else with AI if I could have this. To address what you were saying briefly, yeah, there's absolutely, this isn't some holy grail. First off, want to acknowledge AlphaFold is not perfect. It's just really good. So even in this
I saw that. They said
post, right, they talk about how it helped the humans, but it was this major leap forward that probably would not have been possible before, right? So it'll continue to get better though over time.
Yeah.
And then the other thing is, again, I think the government needs to get involved with this stuff. As much as I generally do actually have faith in Google, they've shown to be well-intentioned with a lot of things like this. I wouldn't trust them. I don't think they should be the ones, hallmarking this stuff. And so it gets back to the abundance thing of I think the government should be incentivizing centralized development of this stuff. But also it's incredible that private companies, this is a private company that did this and has been working on this, and they're continuing to, like, I listened to a podcast by the CTO of one of the kind of twin subsidiaries that work on this stuff, and he's like, our goal is to have like 5 to 6 more of breakthroughs of this scale soon. And we think that will basically, 1000x drug discovery. And there's a lot of just thinking around that. Like another from Dario, who's the CEO of Anthropic. It's my guess that powerful AI could at least 10x the rate of discoveries, giving us the next 50 to 100 years of biological progress in 5 to 10 years. Like the rate is just going to skyrocket. But also it's challenging, yeah. And yeah, I mean, I'm so. I also want to give just really quick, people who are like, Doug, you're way too optimistic about AI. This is why, by the way, this is the stuff that gets me excited. It's not ChatGPT. ChatGPT is really cool, I think, but this is the shit where I'm like, oh my God, we might eliminate cancer. Let me actually quickly go through a cancer scenario. So right now, a early stage treatment for cancer is called T-cell therapy. It's actually CAR T-cell therapy. So again, the core problem with cancer is it's from your body. It's your own cells that have mutated and they're dividing, they're creating too much of themselves. So the body isn't good at recognizing this is a bad thing that needs to be taken out. So what you in theory could do though, is you could take T cells, like, immune system cells out of the body that are normally supposed to attack cancer cells. And you train it to look for specifically what the cancer cells look like. You put it back into the body and then they go in. It's like you like pull out soldiers from the body and you like send them through like SEAL camp, like boot camp, and you train them specifically to go fuck up
Sounds badass.
tumor cells, and then you put it back in. That is working right now. I don't know where. Oh, this is CAR T-cell therapy. So it's called chimeric antigen receptor therapy. It's named after Hunter x Hunter. And it's literally what they do is they grab a T-cell. You can see here on the left, if you pull it up, grab a T-cell from your body. They reprogram it, basically add a little thing to the outside. They like jam a little key on there. Then you send it back into the body and that key fits into the tumor lock and fucking the body goes, oh shit, all right, we got to cure this. And it goes and like expands and works. And this is working right now with leukemia and lymphoma. And it's full on like curing
That's
some
incredible.
of these.
Dude, here's something bad about this. Not bad that the therapy is very cool.
Yeah.
The functionally. But this is something I learned about CAR T-cell therapy about a year ago because I was talking to my doctor friend about what are some fucked up things in the medicine industry. And there's 5 pharma companies that have that do CAR T-cell like treatment. And there's like 5 different types of the treatment that you can do depending on, I think, the type of like cancer you're fighting or the type of treatment that you need.
Okay.
And these 5 pharma companies agreed that each one of them would only do one of the
That's
therapies.
cool.
So they have a full monopoly on each of the therapies and they can charge as much as they want. I learned that. And that's how I learned about CAR T-cell therapy.
Yeah, that's some bullshit.
I mean, this is
Well, so
it's awesome.
Yeah, so let's talk about this. This is right. It's cool, right? It's the idea of you take immune cells out of your body, you program them to attack the tumor, and then you put them back in. But this has the same problem as any other cancer treatment, which is the cancer cells look like healthy cells. And so this same treatment will go attack, it goes into your bloodstream and it helps blood cancer, but then it also attacks healthy parts of your bloodstream. And my understanding is like you can survive this, but then you need blood transfusions and whatever else because it's killing a bunch of healthy stuff.
Yeah.
So even with this crazy ass therapy where we're pulling out, the soldiers of the immune system, we're training them to look for a specific thing and putting it back in, conceptually, that could solve almost anything, right? If you teach the immune system how to go look for this certain type of thing. That's what a vaccine is, right? That's you're teaching it, okay, this is what to look for. And we're manually fucking grafting it like Elden Ring onto the T-cell's body and then putting it back in. But cancer is insanely hard. And this might work for blood cancer, but if you have, again, like pancreatic or prostate cancer or whatever it is, every cancer, not only is it going to be different, they're like morphing. They have all these different ways of expressing themselves. They mutate, and so they have different looks. One of the things you can do is they overexpress, meaning on the surface of it, they have way more proteins or antigens than they should, but that's hard to detect of like, oh, it's more than another cell, right? All you can kind of do is say like, you do or do not have this thing.
Yeah.
But it's hard to tell, oh, you have too much of this thing. And so the same type of treatment is not really feasible right now because we don't have a way to realistically design the super, super precise type of soldier in the immune system that can do all this stuff. But again, that's not impossible. So imagine a world in 10, 20 years where you get cancer and they pull a biopsy of the cancer cells. They look at the tumor cells. And while a human couldn't do this, an AI analyzes the tens of thousands of different proteins on the surface of the tumor and goes, we've actually figured out a pattern. Then, once determining that concrete pattern that makes the tumor cell distinct from any other type of cells in the body, you then have the AI design a molecule using tools like AlphaFold to say, we're going to design a type of T cell receptor that is specifically going to fit on this lock. Even though that's insanely complex, but we have the data and ability to do it because it's an AI. We put that onto the T cells, put that back into the body, and it fully kills the cancer.
Dude, that is so
That's feasible within our
fucking
lifetimes. Absolutely. And the challenge here is like the immense amount of data complexity and processing and the amount of time. But if all of these tools are able to be incorporated into an AI system that can, for example, actually crystallize these CAR receptors and put them on the thing, so the timeline is also reduced. Like we could cure cancer straight up. And you can imagine this happening for everything else, all the complexities of diseases that we currently deal with, like Alzheimer's, where we kind of don't really know what's going on. If we can crunch the numbers on what's going on with a sample of neurons, an AI could identify a specific way to actually attack it. And this, because of AlphaFold last year, this isn't fantasy stuff. This is like, yeah, we see a path through this right now in our lifetimes in 10, 20, 30 years.
I mean, okay, this is